Hi guys, this is the video for chapter 10, lesson 4. It's the last lesson of chapter 10. After this, you'll be taking your test. So I would encourage you to look back over everything that we've done, maybe rewatch the videos and prepare for your test after this class. So last class, we took a look at triangles and classified them by their names, discovered that all the angles of a triangle always add up to be 180 degrees. Well, today we're going to learn a new idea related to their sides. So last class we looked at their angles. This class we're looking at their sides. So the special type of triangle we're going to focus on today is a right triangle, okay? And so something that's kind of interesting is that my right triangle, if I didn't know some of the sides, like let's say this is 3, this is 4, and I don't know this side, there's actually a method for us to find the third side of a right triangle if 2 of them are given to us. And so I don't know if this is something you've looked at in your previous math classes, but a really smart guy named Pythagoras discovered this idea. And so therefore we've named this idea after him. We call it the Pythagorean theorem. So I'm going to explain that to you. I'm sure you've heard that word before, but I'm going to show you just a little picture from a video here that if we are looking at a right triangle, for example, and we squared each side, see how this side is 3 units long and this bottom is 4 units long? Well, if we squared 3, that will be 9 units. So you can see it's even a square is created out of the units here, each box. And then the bottom, if 4 was squared, we would have 16, so we count out there's 16 boxes here. And if we add these up, that equals the square of the third side. So the third side is 5 units long, and 9 plus 16, if I calculate that out, is 25. And so if I count this out, it's a 5 by 5 squared, so it's 5 squared, which is 25 units big. So I'm going to play this video and let you watch it and kind of see what's going on here, and then I'm going to show you another really cool thing. Okay, I'm going to pause it there because it's basically the same thing. But here is our Pythagorean theorem. Each side, if we classified it one side as A, one side as B, and one side as C, A squared plus B squared equals C squared. Now, C squared is always the longest side. So let's write this in our notes. And I'm going to just take off this information here. And I'm going to name these. I'm going to call these the legs, okay? So the 2 sides that kind of sandwich the right angle is they're called the legs. The 2 legs create the right angle. And then the third side, the longest side, is what we call the hypotenuse. So instead of saying A squared, which I'm going to put in parentheses, A, B, and C, instead of saying A squared plus B squared equals C squared, I'm going to say that our Pythagorean theorem basically is saying leg squared plus leg squared equals the hypotenuse squared. Because that way you know exactly what A, B, and C represent. Now that third, like C squared, has to be the longest side. It's the 2 shorter sides squared add up to be the longest side squared. So, you know, if I had you know, a triangle where this was 5 and 12, and I wanted to find the third side, I didn't know what that is, I could plug that in my equation and say, okay, 5 squared plus 12 squared equals x squared. And so now we're going to practice using some algebra and practicing our squares and square roots, which is a new concept for us. So this is really where all that kind of comes together. So 5 squared, you can use your calculator. So 5 squared is 25. 12 squared, if you remember, if you've memorized all your squares up to 17, you know that 12 squared is 144. So 144 plus 25 equals x squared. When we add these together, we get 169 equals x squared, and we now have to square root both sides to get x by itself, because the opposite of squaring is to square root. So square root of 169 is 13. And so our third side here, the hypotenuse is 13, and we actually found that distance using the Pythagorean theorem, which is kind of cool. So let's take a look at another pretty cool video. This video is a visual where a teacher uses a water demonstration, and the water is dyed blue, and she shows, we don't know the measurements of of all the sides. It doesn't classify the measurements of the sides, but we see this little wheel thing, and the blue water fills up the whole square, and when she turns it, we see that and the reason these are squares is because it's the side squared, which means that side times itself 2 times, and that's the area of a square, right? And so when she turns it, we see that the water flows into the square of the hypotenuse perfectly, fills it up perfectly. See that? So, and then when she turns it back around, this whole square fills up the 2 other ones perfectly. So that's a really cool visual that we can see how the Pythagorean theorem works. So we're gonna just practice this a little bit, and you probably don't have enough room on your study guide to fill all this out. So I would like for you to do this on a piece of paper, but we're gonna really practice writing out our equation and showing our work very clearly. So number 1, first of all, we need to identify what our hypotenuse is, and it looks like they've labeled the hypotenuse as C in all of these pictures. And so that's a nice thing, is they're only having us find the hypotenuse. So number 1, we're going to write this as 20 squared plus 15 squared equals C squared, okay? And then we can plug this in our calculator. So 20 squared is 400, and 15 squared is 225, and now we add them together, and we have 625 equals C squared. So to work this out, just like we learned in our first lesson in this chapter, to solve a square, to do the opposite is to square root. So the square root of 625, plug it in your calculator, is 25. Okay, so C equals 25 here, which is awesome. C equals 25, okay? Number 2, now we might see some decimals. So if we see a decimal, we're just gonna round it to the nearest tenth. Now I'm gonna write this up here. I hope I have room. So 11 squared plus 12 squared equals C squared. So 11 squared is 121, 12 squared is 144. So we have 121 plus 144 equals C squared. Add them up, you get 265. Now notice how I'm showing every step by step. I'm gonna be a stickler on this one. I wasn't on the last one, and I tell you, I verbalize that and I say, I want to see your work, or I don't care if I see your work, I just wanna see the equation. This one, I wanna see your work. So we're gonna square root both sides, and ooh, it's a decimal. Plug this in your calculator. 16.27, so rounded to the 10th is 16.3. And that's the distance of this third side. Okay, I'm just gonna do one more. I'll probably do 4, and then I'll put up the answers for 3, 5, and 6. You can work those out and double check to see if you're doing it right, okay? 6 squared plus 6 squared equals c squared. 6 squared is 36. So I have 36 plus 36. And 36 plus 36 is 72. Square root both sides. 72 square rooted is 8.48. So rounded is 8.5. There you go. Okay, so let's check our answers for the problems that you did on your own. Numbers 3, 5, and 6. I didn't write out all the steps, but I put down the answers. I put down the original equation and put down the answers rounded to the nearest 10th. Number 3, it was 43.0 something, and so rounded, I was just gonna write it as 43. Okay, let's take a look at 7, 8, and 9. Now, we don't have pictures here, but it's telling us that C is the hypotenuse, and we're gonna find the missing measurement. So number 7 is the same as the other ones that we've done. Basically, you're just going to do 18 squared plus 80 squared equals c squared. So if you work that out on your own, you should get 82 as your answer. And that's just the same as the problems we did above, just without a picture. Now let's try number 8. So in this case, we're missing a, okay? So if our equation is a squared plus b squared equals c squared, then what we're missing is a, and so we're gonna leave that as, well, we could leave that as a squared. So I'm gonna put our equation down here, number 8, a squared plus 70 squared equals 74 squared. This time we have the c squared, we don't have the a squared. So we're just gonna leave that as what we don't know and then fill in the rest of the stuff. So then when we work this out, we can't solve a squared, but 70 squared is 4,900. And then 74 squared is 5,476. So when we have a problem like this, we need to get a squared by itself, which means we have to subtract 4,900 from both sides. 4,900 from both sides, we're gonna subtract. And then when we subtract it all, we get 576. So when now we can square both sides, because all we have left is a squared equals 576. And when we square root that, a equals 24. Okay, so see how the process of working this out was just a little bit different from my other problems, but if you know the general ideas of solving an algebraic equation, you should be good. So let's do number 9. Number 9, I'm going to fill in my information using the Pythagorean theorem. 14 squared plus b squared is what we're missing, equals 22 squared. So 14 squared is 196 plus b squared, and then 22 squared is 484. Okay, I need to get b squared by itself, so I'm going to subtract 196 from both sides. And then I have b squared equals 288. Now I'm going to square root both sides. And when I plug this in, I get 16.97, which makes this about 17. So when you round it, it's about 17. And because it says round to the nearest 10th. So when I round it to the nearest 10th, it bumps it up, makes it 17. Okay, I want you to try 10 on your own. So pause the video, try 10 on your own. It's just like number 8, and then check your answer. I'm gonna put it up here, okay? A equals 330.7. So that is your answer there. All right, so you guys now know the Pythagorean theorem. That's a big one. You're gonna use that a lot in the future. So remember that, store that in your memory chip, and it will be reviewed again a lot in the future. So the last thing we're gonna do is basically decide if a triangle is a right triangle if it fits the Pythagorean theorem, because the Pythagorean theorem only works if a triangle is a right triangle. If it's not a right triangle, this a squared plus b squared equals c squared thing doesn't work out. So basically what we're doing is we're given the sides and we're going to just double check. We're going to write out our Pythagorean theorem. 5 squared plus 15 squared equals 17 squared. And we're going to double check. 5 squared is 25. 15 squared is 225. 17 squared is, I don't remember this one as well. Hopefully you have it memorized by now, is 289. And so we're going to check, is 25 plus 225 289? No, it's 220, 250, sorry, 250. That is not 289. It does not equal. So when we look at this, we realize it can, because the squares of the legs don't add up and equal to the hypotenuse squared, this is not a right triangle for number 1. Okay, let's try 2. So we're going to plug this in. 5 squared plus 12 squared equals 13 squared. 5 squared is 25. 12 squared is 144. 13 squared is 169. When we add these up, we have, 169 equals 169. You know what? That works out. They are equal, and so this is a triangle. Yes, it's a right triangle, okay? Okay, so I'm going to pick out a few for you to do. We're not going to do all of them. Let's do 5, 8, and 9. Okay, we'll do these 3. So pause it and work them out if you need to. I already know number 5, it does not equal, so this is not a right triangle. And I guess you can verify it by saying this is 106, right? It does not equal 169. Okay, so 18 squared, 324, 24 squared, 576, 30 squared is 900. And it does equal. Okay, so this is a right triangle, yay. Last one. So 20 squared is 400. 24 squared is 576. 26 squared is 676. I don't think that's gonna add up, right? 400 plus 576 is like 900 something, 976. So no, doesn't work. No, not a right triangle. Okay, hopefully that makes sense. You can do a few more as practice if you want to, but the Pythagorean theorem actually can tell us if a triangle is a right triangle or not, as well as help us find the missing sides. So it has multiple purposes. All right, and that's all I have for you today.